Ahoy hoy, I'm Planet Walk, and today we're going to be taking a look at someone called Bill Gaede. Or is it Bill Gaede? I'm not quite sure on how to pronounce his last name. Anyway, the first time I heard of Bill was actually due to the fact that he debunks Ken Wheeler. And so my first thought was, oh, finally, someone who's not myself and AB Science is debunking Ken Wheeler. But I never actually watched his videos until I received this comment here. There is only one person that truly understands physics. It is Bill Gaede at Rational Science. Look him up and you'll be amazed. So this comment made me think, if this person is saying that there's only one person that truly understands physics and it's Bill Gaede, then Bill Gaede probably doesn't understand physics. Now my quack meter was going off, so I searched up Bill Gaede, and to my amazement, I'd searched him up before. I'd searched up Bill Gaede, Ken Wheeler. Or maybe I searched up Rational Science and then it came up with Ken Wheeler. Either way, I realized, oh, I haven't watched this person's videos yet, and I said I was going to watch them ages ago. So I decided to take a look at a video where he criticizes Ken Wheeler. And to be fair, a lot of his criticisms were quite valid. He points out how Ken Wheeler uses big fancy words like incommensurability, although Bill said it incommensurability, which makes it sound more like the measurability of an income that people make. But as Bill pointed out, because Ken Wheeler uses big fancy words, it makes him sound smart. And because he sounds smart, people take him seriously. The point of Ken Wheeler's videos isn't that you understand what Ken Wheeler is saying. It's that Ken Wheeler says stuff that sounds like he's really intelligent, and if you watch enough of Ken Wheeler's videos, then one day maybe you too will truly understand the universe. But anyway, this is not a video about Ken Wheeler, although I probably will bring him up at some point throughout the video. Although, I don't have a script for this, so I don't know. Do you think my ADHD allows me to write scripts? But anyway, when watching Bill Gaede's criticism of Ken Wheeler, there was one thing that kind of stuck out to me. The fact that he said that fields don't exist. And that was kind of funny to me, because fields, they do exist at least to some extent. Take, for example, the temperature field. The temperature field is a thing that exists everywhere, and wherever you go, you get a temperature. Cool. Does the temperature field exist? Not really. Sure, wherever you go, you get a temperature, and temperature fields can be used to easily represent temperature. But the temperature field is not required to explain temperature. On the other hand, the magnetic field, that doesn't appear to have any other underlying thing that can explain it. So when a field is the best explanation for a phenomena, does that field actually exist? I'd say probably yeah. But the thing that really made me start to question Bill Gaede was when he says that he has debunked Einstein and relativity. Why are there so many people that think that they can debunk Einstein?
Oops.
I mean, yeah, Einstein's theories of relativity are not perfect, but scientists know about the flaws of Einstein's theories. It seems that most people that try to debunk Einstein's theory of relativity don't understand Einstein's theory of relativity. But anyway, like Ken Wheeler, Nigel Cheese, and pretty much every flat earther ever, it seems that Bill Gaede has his own idea about how reality works. And he calls it the rope hypothesis, and I actually have to give him some credit for that name. Him calling it a hypothesis and not a theory at least shows that he has some understanding of the difference between, theory about how it's used in scientific terms and theory how most people tend to interpret it. But that being said, I am going to call the rope hypothesis silly string theory because it sounds a little bit like string theory, but just sillier. So let's have Bill Gaede actually try to explain silly string theory to us. And just reminder, this video is from 10 years ago, so the quality is not the greatest. I mean, my video here is from 2022 and the quality isn't the greatest, so imagine being from 10 years ago. Although part of that might have to do with the fact that my chair looks like it's about to fall apart, my keyboard actually is falling apart, and I have a random microphone there that I don't actually use for these videos.
The electric universe, indeed the entire mathematical establishment, believes that light is an electromagnetic wave.
So it's good that he's against the electric universe, but comparing the electric universe with the scientific establishment, these two things are not comparable. One is a nutty idea created by pseudoscientists, and the other uses observations, evidence, and experiment to arrive at its conclusions.
The mathematicians routinely illustrate their abstract wave as a bunch of mutually perpendicular lines. The mathematical wave consists of an electric field and a magnetic field. In this scheme of things, wavelength is defined as the horizontal distance between peaks, and amplitude as the vertical distance between peaks. The electromagnetic wave of the religion of mathematical physics travels one way, in a single direction, and for never explained reasons oscillates around an axis.
So I will admit that I do not completely understand light. It is one of those things that can be quite confusing. But the way that I understand it is it's not light that oscillates around a single axis, it's just the waveform that oscillates around a single axis, and the waveform then moves across space. Feel free to correct me if I'm wrong, but I think that explains it quite well.
Frequency is defined as the number of peaks per second. Physics, however, is first and foremost the study of objects. We cannot do physics without objects. What would there be to study? What would there be to see? What experiment can you run without an object? Even thought experiments are done with images. Unfortunately for our misguided mathematicians, there is no object in physics called a wave. Wave is not what something is, but what something does. The wave of mathematics is not a noun, but a verb.
Alright, so there's a lot to unpack here. Let's start with the thought experiment part. Why do we do thought experiments with objects? Because monkey brain understands objects best, that's it. And the second is about physics being the study of objects, which isn't really true. Take for example the vacuum energy of empty space. That is not an object, yet it is something that physics deals with. I'd say that physics would be best defined as the study of the mechanics of reality. That may be a bit of a broad definition, but I think that encapsulates all of physics. And lastly, he stated that a wave is not a noun, but a verb. And to that I say, I don't care. All I care about is whether something is an accurate descriptor of what is happening. Is light being a wave an accurate descriptor of light? Yes. Is sound being a wave an accurate descriptor of sound? Also, yes. Is there more to sound than it just being a wave? Yes, there are compressive forces going on that make areas of low pressure and areas of high pressure that causes what we perceive as sound. So is sound a noun or a verb? Well, according to Google, yes, but I don't care as long as it describes the thing that it is describing.
Likewise, there is no object in physics known as a field. The word field is also a concept, and as such, it doesn't belong in physics as a physical object.
Whether a field is an object or not, we still see the effects of fields, whether the effects be gravitational lensing, whether the effects be magnetism. Those effects exist. Something is causing that to happen. Could there be something aside from the field that is causing those effects? Yeah, that is the case for temperature after all, but we're still going to use fields.
If light interacts with matter, we have no choice but to replace the abstract wave of mathematics with a physical entity.
Now, depending on what you mean by physical entity, I'd say that light waves are indeed a physical entity. If you can't wrap your head around it, that doesn't change whether it is or not.
It is thus that we replace the mathematical wave with a physical rope-like mediator. The physical electromagnetic rope is comprised instead of a magnetic thread and an electric thread. The wavelength of mathematics now becomes the length of a link, and the rope's amplitude is given by the height of the threads.
So the problem here is that this does not remove the need for an electric field and a magnetic field. You've got a magnetic rope and an electric rope. How do they interact with anything? How are they different?
The anti-parallel threads of a taut rope have no choice but to coil around an imaginary axis. Whereas mathematical waves travel in a single direction, torsion along the rope travels in both directions simultaneously.
So I'm not sure what he's talking about when it comes to torsion here, but it sounds like he's talking about light being torsion or something. And in that case, light does not travel in both directions, it only travels in a singular direction.
The rope and the wave come to a head when trying to explain physical phenomena. For instance, the mathematical establishment has no idea what physically restrains light to a constant speed as specified by its very own wave equation.
So the reason why the speed of light is constrained is because that is the universal speed limit on everything in the universe. For example, gravitational waves can move no faster than the speed of light. Perturbations in electric or magnetic fields can move no faster than the speed of light. The reason why it's called the speed of light and not the universal speed limit is because light was the first thing that we noticed that had this speed. By measuring the speed of light, we found that light has a speed, but then we also later found out that, oh wait, this speed is the universal speed limit.
Why does frequency go up when the wavelength goes down and vice versa? Here we have 6 waves, each 1 centimeter long, passing a given point in 1 second. What physical reason is there for the frequency to drop to 3 waves per second when wavelength increases to 2 centimeters? What physically prevents both the wavelength and the frequency from increasing so that light can travel faster?
Oh boy, you see, you can't just accelerate the speed of light by increasing its wavelength. That's not how any of this works. This is like asking, why doesn't my car go faster when I add more petrol? Adding more petrol to your car does not make it go faster. Increasing the wavelength of light does not make it go faster.
Under the rope model of light, the longer you make the links, the fewer links you can fit in any given length of rope. The rope model justifies why frequency and wavelength are inversely proportional, and why light is a constant.
I'm sorry, Bill, but you haven't solved any problem here. It seems that you just misunderstood things.
The mathematicians also have no clue why the speed of light is independent of the speed of its source. The reason so many mathematicians today still search for speeds faster than light is that they see no reason why the 2 speeds shouldn't be added.
So the reason why you can't just add 2 speeds to make the other speed go faster than light is because nothing can go faster than light. If nothing can go faster than light, you can't add speed together to make something go faster than light, because that just doesn't work. Now obviously the full explanation is far more complicated, and that goes into things like Einstein's theory of relativity and involves time dilation. But that explains more why the speed of light is the exact same in every reference frame.
Under the rope model, when an atom is approaching another one, it reels in the electromagnetic threads which now form part of its body. An atom slides along any given rope like a bead on an abacus. This is how Mother Nature secretly does this magic trick. Under the rope model of light, there is no mystery as to why the speed of light is independent of the speed of the source.
My question here would be, and I don't think Bill Gaede has an answer to this, how does this explain the fact that the speed of light is constant no matter which reference frame you are in? And the reason why we know that the speed of light is the same no matter which reference frame you are in is the Michelson-Morley experiment. If the speed of light was independent of reference frame, then that experiment would have given evidence for the luminiferous ether, but it did not.
To make matters bleaker for the quantum wave, an atom allegedly manufactures light when the electron bead quantum jumps. This signal, energy, radiation, or whatever, travels off to nowhere and comes from nowhere.
So here what he's talking about is electrons changing energy state and emitting photons. When an electron changes energy state, that changes the amount of energy within that electron. If it absorbs a photon, then it gains more energy. If it emits a photon, then it loses energy. So this means that the energy doesn't come from nowhere, it comes from the electron. I don't know what he means by the light travelling off to nowhere. If he means that, it's just travelling off in a random direction, yeah, most light does that, doesn't it?
A pertinent question then is whether a wave manufactured in an atom of the Andromeda galaxy travels like a sailboat through the cosmic ocean all the way to Earth, or extends from there all the way to here. Where does the mathematical wave begin? Where does it end?
The same kind of thing can be said for any kind of wave though. Where does a wave on a pond begin? Where does it end? Where does a sound wave begin and end? That question doesn't really debunk light being a wave.
Under the rope model, an atom in the Andromeda galaxy is permanently bound to any atom comprising the solar system. The electromagnetic rope interconnects any two atoms in the universe. Torsion has no chance of getting lost irrespective of where an atom moves. Whereas quantum mechanics proposes that atoms are discrete independent entities, the rope hypothesis proposes that all atoms in the universe are interconnected.
I can see this getting quite messy quite quickly. If most atoms in the universe were indeed connected, don't you think those ropes would get tangled pretty quickly?
What is perplexing is that there are people out there who still don't understand the difference between an object and a concept. As far as all these neophytes are concerned, all we did was assign a new name to the infamous field of mathematics. So let's clarify the difference.
Field is a concept. A thread is a physical object. A thread physically binds two atoms to each other. A concept such as field is like the concepts love and information. Concepts cannot pull two atoms together or perform any operations in the physical world.
So it looks like I'm going to have to explain where exactly concepts come from. They come from us observing phenomena and trying to explain them. For example, force is a concept used to describe something that actually happens in reality. Acceleration is also a concept used to describe things that happen in reality. All acceleration is the concept of things speeding up over time. What we have there is a concept to help describe objects. For the magnetic field, that is describing the force due to magnetism at any given point. Is there an underlying physical thing there? I don't know. There could be, but I'll just treat it as though it's the field because that's the simplest thing that we've got there to describe the magnetic field.
In the religion of mathematical physics, an electron orbits the nucleus. The mathematicians have re-engineered this atom over the years, and today claim that the electron is really a fuzzy cloud that envelopes the nucleus.
So this is a very good picture of a hydrogen atom with an electron in the lowest energy state. The electron occupies a cloud instead of an orbit.
But this is a circular argument, because the mathematicians allege that this cloud is a region where we can find an electron.
Now, what's a cloud? A cloud is an area where there's the most probability of finding an electron.
So obviously Bill Gaede here does not know a whole lot about quantum mechanics. Yes, it's confusing, but it is understandable. So the electron cloud is where an electron could be at any given moment in time. So let's say that you put a hydrogen atom in a box and you close the box. Now, when that hydrogen atom is in the box, you don't know where the electron is in the electron cloud. But when you open up the box and look at it, the electron is in one single place in that cloud. And when you close the box again, all of a sudden, that electron can be anywhere in the electron cloud again. You open up the box, and then you find the cat in the box has died. Now obviously it is a little bit more complicated than that, but that is the general idea.
So is the electron a bead that orbits the nucleus? A cloud that envelopes the nucleus? Or is a cloud a region around the nucleus where we can find the electron? What cloud of electrons can a hydrogen atom have if it has a single electron?
Well, it's the region where we can find an electron, and it also describes the most probable places within that region to find an electron. But whilst the electron is not being observed, it's treated as though it's in all of those places at the same time.
Under the rope hypothesis, the atom finally receives a rational physical interpretation. The electric and magnetic threads fork at the boundary of an atom. The electric thread continues straight to the center of the atom and out the other end. The magnetic thread, meanwhile, curves around and forms the electron shell. The electric threads from every atom in the universe converge upon a given atom, forming an urchin-like star at its center. Meanwhile, the magnetic threads weave the electron shell that encapsulates the proton.
My question here would be, if this is the case, then how can an atom become an ion? Does ionizing radiation somehow carry the capacity to untangle a whole lot of threads and then separate them from the atom somehow? And if every atom in the universe is connected in this way, then that means that there are a lot of threads there. And I'm talking an unfathomable, did I get that right? I hope so. I'm not trying again. Amount of threads there. Like so many threads that our monkey brains would not be able to comprehend the amount of threads that would be in a single atom, if what Bill is saying is true.
The atom is an urchin-like star, encapsulated within a shell, the surface of which resembles a ball of yarn. When the atom contracts, it releases links of rope radially. And when the atom expands, it draws in thread to make up for the larger atom. This so-called quantum jump torques the rope. The atom is a little heart pumping torsion waves called light to every atom in the universe.
Alright, so there are a few problems with that. First of all, it does not explain gravitational lensing. In case you don't know, gravitational lensing is when gravity bends light. Simple as that. Bill's silly string theory makes it sound as though light travelling from a distant galaxy would only travel in a straight line to get here, even if it passes by a gravitational field. Observations from Hubble show that this is not the case. In fact, the same supernova was witnessed 4 different times at 4 different apparent locations due to gravitational lensing. Silly string theory also cannot explain the double slit experiment, which, kind of relies on light being a wave to work. If Bill Gaede's idea of how the universe worked were true, then the double slit experiment simply would not give the results that it does. Another problem with what Bill has been saying is that he doesn't seem to understand half of the things that he's talking about. For example, right at the end there when he talked about atoms quantum jumping, he says that they pump out light to every other atom in the universe. That is not the case. They just shoot out a photon of light in a random direction. But anyway, that was Bill Gaede's first video on the rope hypothesis, or as I call it, the silly string theory. If you want more videos on Bill Gaede, let me know in the comments. But anyway, leave a like and subscribe if you liked the video. Make sure you join my Discord, there will be a link in the description. Hit the bell notification icon so that you get notified of when I post new videos, all that good stuff. As always, a big shout out to my $20 or more patrons. Hugh Jarsz, M.C.Nutkin, SHaKie, Wolfie, Morrie, Graymore Ghost, KidVicious, and Sacha Campbell. If you want to support me financially, you can do so on Patreon. There should be a link there. But anyway, I will see you in the next video. Between you and me, thank you for watching. Wait, I forgot to mention Ken Wheeler too many times.